Hey, what's up guys? Back again with another video. This time I'm going to show you how to do base conversion from decimal to binary and binary to decimal. So yeah, this is something I'm learning in college for my computer science courses, like discrete math and other stuff, obviously that's very important, knowing binary and stuff like that. And so I learned how to do it a little bit, so I just want to show you what I've learned so that you can know how to do it too. So yeah, I'm not going to go too into detail in this video on what decimal and binary is. Obviously you know what decimal is. If you don't know, that's just the same like number system that we use, 1 2 3 4 5 6 7 8, all those numbers. That's decimal, like the human system. And then we have binary and hexadecimal and other systems, and they are for different bases, and so it's different ways to represent numbers basically. And binary is obviously another very popular one when it comes to computers, because as the language of computers operate in binary. And yeah, so most of the time you're going to see something like this. So 1 0 1 1 0 1 1 0. This is an example of something binary. It's just a mix of ones and zeros, and you can often represent 1 as true and 0 as false, stuff like that. And so yeah, that's a brief overview of binary, and obviously you can mix it up so you have different combinations of ones and zeros, and that represents different things, different numbers and stuff like that. And so obviously it's hard for us to understand binary as a human being. You can't read this and automatically know what it is unless you're like a savant or something like that. So it's very useful for you to know how to convert between binary and a decimal. That's a very important skill, okay? So just a quick other thing, binary is the same as, it's called base 2. So you have a base and then x kind of, and then we have decimal, which stands for 10. Deca I think represents 10, and bi obviously represents 2. So then we have 10x, and x can be any number, right? And yeah, like I said, I'm not going to go into too much detail on that, so let's just move on to the conversion, which I want to show you this episode. So we're going to do base conversion from decimal to binary. And don't roast my handwriting, please. I'm trying my best. I have this little tablet thingy I'm using. So base conversion from decimal to binary. And let me just scroll down a little bit. And so let's have the first problem here, which is going to be number 1. Convert, oops, I have shapes turned on. Let me turn that off. So boom. So convert the number 25 into binary. Okay. And so to do that, we can break it down into the powers of 2, because binary is 2, so the base of 2. So let me just select this, and so let's break it down. So usually when you see a binary number, by the way, it's split into usually 8 digits. It can actually go beyond or before that. It doesn't have to be 8 digits, so it can be lower than 8 digits or greater than 8 digits, but that's the most common way to represent it when you have small numbers like this. So the common way to represent binary is usually 8 digits. So let me give you an example. So 1 0 1 1 0 1 0 1, that's 8. So 1 2 3 4 5 6 7 8. So each of these digits here are bits, and so we have 8 bits. And so a unit of 8 bits is equal to 1 byte, just in case you did not know that. And so what we can do that's very useful to break it down into the powers. So if we do 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. So let me just draw a little box here. Let me go click shape, box. Okay, cool. So now we have this little box here. So as you can see, we have these powers of 2, which is again why it's called base 2, binary. And so now we just calculate what each of these bases equal. So 2 to the 0 is going to be 1, because anything to the power of 0 is 1. 2 to the 1 is 2, to the 2 is 4, 8, 16, 32, 64, and 128. And these are actually common numbers. If you study computer science, these are common numbers you'll be seeing. Beyond 28, you get 256. Beyond 256, you get 512. Beyond 512, you get 1024, which are common memory amounts when you get down to low amounts of memory. Anyway, I'm ranting a little bit, but so now what we want to do is we have the number 25, and so we want to find the highest number that can fit into 25. So the highest power of 2 that can fit into 25. So does 128 fit? No. Does 64 fit? No. Does 32 fit? No. Does 16 fit? Yes. So 16 fits into 25, so we can mark it as a 1 for true, or however you want to represent it. And so these are going to be 0 because they do not fit, and then these other ones we still need to determine. So once we have found the highest number that can fit into 25, we can go into the side here and do 25 minus 16, and that's going to be 9. So now we have 9. So what is the highest number, the highest power of 2 that can fit within 9? Obviously, the next one is 8, so 8 does fit, so we can put 8. So 9 minus 8 is 1, so then now we have a leftover value of 1. So what is the highest power of 2 that can fit within 1? Not 4, not 2, but 1. So we have found the 3 powers of 2 that can fit within 25. So let's just do 1 minus 1, obviously that's 0. And so now what we can do is just mark these. So the ones that are fitting into the number that you're trying to convert, you can mark as a 1, and the other ones are zeros. So there we go. Now we have converted a decimal number, which is just, normal human being numbers, and then we converted that to a binary number. So we can go down here now and say we can go from left to right, or right to left. So 1, 0, 0, 1, 1. And you can leave off the trailing zeros if you want to, because there's no 1 after that, right? So, yeah, this is how you convert 25 into binary. That's the answer, 1, 1, 0, 0, 1. Okay, so let's do another problem just so we can get the repetition down and actually remember how to do this, because repetition is very important when you're memorizing something. So convert the number 12 into binary. Okay, so this is a smaller number, so hopefully it can be easier, right? So now what we want to do is kind of do what we did before. You can do it however you want to, but the easiest way is just to write out the powers, or the result of the powers of 2. You don't have to write these every single time. You can just write the values they represent. So we can do 1, 2, 4, 8, 16, and obviously it's easy to remember because it's just times 2 every time. And the more you do it, the more you'll start to remember it anyway. It's a pattern. So 64, and 128. And now again, we just need to find the biggest power of 2, which is these numbers here, that can fit within 12, the number we're converting. So in this case, 16 does not fit. Any of these do not fit, so we can just mark them as 0, right? And then 8 does fit, so we can mark it as 1. Go to the side here, 12 minus 8, it's going to be 4. And so 4 does fit. That's the next number that fits into the result here. So 4 minus 4 is 0. So now we don't need any more because we have successfully found the 2 digits of the binary number that we can use here. So anyway, now we can take that. So now we can take that and then make our binary number. So we can just represent it as 1, 1, 0, 0. Again, you can chop off the trailing zeros, but make sure you keep on the it's from right to left, right? So make sure you keep the beginning zeros, obviously, because that's very important. And so there we go. So we get 12 to 1100 in binary, and that's how you convert 12 to binary. And let's do one more decimal to binary problem here. So we'll do 3, and we're going to make this one a little harder by giving us a bigger number to convert. So convert the number 500 into binary. Okie dokie. So now let's write out the powers of 2. So 1, 2, 4, 8, or not the powers of 2, but you know what I mean. I mean like 2 to the 0 to the 1, like the actual answers of them. You know what I mean. So 1, 2, 4, 8, 16. Let's try and keep it on the same line here. So 16, 32, 64, 128. And 128 is obviously going to fit into 500, but we want to find the largest number that can fit into 500. So let's see what the next one is. So 256. So 128 times 2 is 256. And then 256 times 2 is 512, I believe. Let me double check. So 256 times 2 is 512. I have a calculator here. So there we go. So now we have found a good amount of digits to have here. So let's just put a line. And so again, we just want to find the highest number that can fit into the number we're converting. So in this case, 512 is very close, but it's over the number. So we want the next one. And 256 does indeed fit into 500, so we can use this one. So that's going to be a 1, that's going to be a 0, because it doesn't fit, obviously. And so we'll go to the side here and do 500 minus 256. And let me just whip out my handy dandy calculator and just do the subtraction here. So that'll be 244. So 244. And now we want to find the next biggest number that can fit into 244. So 1. So 128 minus, or 244 minus 128, and that's going to be 244 minus 128, 116. So 116, oops. And now the next number that fits into 116 is 64. So 64, and so we'll do the subtraction. 116 minus 64 is 52. 52, boom. And we'll fit 32 and 52. So 52 minus 32 is 20. And so what number fits into 20? 16. And we get 4. So now what number fits into 4? 8 does not fit into 4, so that's 0. 4 doesn't fit into 4, so we'll put 1. And then we have 4 minus 4, 0. Nothing left over, so we can just put these as 0. There we go. So now we have our final binary number, so let's just write it out here. And we'll say is equal to 1, 1, 1, 1, 1, so 1, 2, 3, 4, 5, 0, 1, 0, 0. And so we'll do 500, and that is indeed 1, 1, 1, 1, 1, so 5 ones, 0, 1, 0, 0. So that's correct. Cool. So that's how you convert decimal numbers into binary numbers. So hopefully you have the pattern down. So you should be able to convert any reasonably small number into binary. Obviously when they get bigger, it gets a little more tricky, or at least more time consuming, more tedious, but that's how you do that. Okay. All right, so now let's try converting binary to decimal, so the other way around. So we'll go here and say conversion from binary. And I'll leave the notes in the description below. I know it's a little hard to read because my handwriting is bad, but in case you want to have the notes, I'll leave them down for you in the description so you can download them and print them out or something like that, whatever you want to do. So conversion from binary to decimal form, okay? And let's make some more space here. So let's have the first problem here. And we'll say number 1, convert, I'm just going to make up a number, 0, 1, 0, 0, 1, 0, 0, 1 to decimal form. Decimal form. Okay, cool. All right, so convert the number 0, 1, 0, 0, 1, 0, 0, 1 into decimal form. And so now if you know how to convert decimal into binary, for me at least, it's easier to convert binary into decimal since you know the pattern. So in this case, what we can do, there's multiple things you can do, it's up to you, but the way I like to do is just to write it out again, clearly, 0, 1, 0, 0, 1, 0. And we can even chop off the ending 0 because that doesn't mean anything, right? But we'll leave it. There we go. Okay, cool. So then we'll draw a line underneath. Draw a line underneath. And we're just gonna write the powers for each digit of this binary number, right? So we know the first one's 2 to the 0. We know the second one's 2 to the 1. 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and 2 to the seventh. And so now for each of the ones that are 1, we can represent that as true, right? So we can do 2 to the sixth, which is indeed 64. And obviously the ones that are 0 are not true, they're false, so we can pretty much ignore those, right? So 2 to the sixth, 64. The next one is 2 to the third, and that's going to be 8. So 2 times 2 times 2, obviously. So 8, and the next one's going to be 2 to the 0, which is 1. And so now we can just add each of these numbers here, and that's going to equal 73. Cool. So 64 plus 9 is 73, so 8 plus 1 is 9. And yeah, there you go. That's really all you got to do for converting binary to decimal. So let's do another one. Hopefully you find it as simple as I do. So 2, and we'll say convert 11001011. Let me fix that. There we go. So 11001011 to binary. I mean decimal. You know what I mean? All right, cool. So first let's write it out again like we did last time. So let's move down a little bit. So 1 1 0 1 0 0 1 1. Okay, cool. And again, we'll just write the powers of each 2 base. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5th, 2 to the 6th, and 2 to the 7th. Sorry for my bad writing there. And again, we'll just take the 1s and convert them into, or do the calculation. So 2 to the 7th is going to be 128. And then again, we have another 1 here. So 2 to the 6th is going to be 64. And then we have 2 to the 3rd, so plus 8. 2 to the 1 is plus 2. And then 2 to the 0 is plus 1. And again, all we have to do is add these numbers here. So that should be equal to 203. So you can check me on that. But 128 plus 64 plus 8 plus 2 plus 1 is equal to 203, if I'm not mistaken. So yeah, that's how you convert 11001011 into decimal. And let's do a third example. So this time we're going to convert 10101010 to decimal form. So a nice pattern. Let's see what that equals, right? Okay, cool. So I'm going to show you a little bit of a different way to do this one so you can think of it maybe more clearly than I've been doing it so far in terms of converting from binary to decimal. So let me just select the ink to shape here. And we're just going to draw a little box. That's sideways, oops. Okay, cool. And we want to fit each of these digits here, the binary digits, into the box. So 0, 1, 0, 1, 0, 1, and we want 4 of them, right? Or I mean 8 of them, right? So 1, 0, 1. There we go. So 1, 2, 3, 4, 5, 6, 7, 8. And so this time, let's do it a little differently. So let's go down here and we'll write the result of this. So we can do it as 0 times 2 to the power of 0. And that's going to be equal to 0 times 1, which is 0. Anything times 0 is 0. And so we can go down with this one. So the second digit. So it's going to be 1 times 2 to the 1 is equal to 1 times 2, which is 1 times 2, which is 2. So as you can see, we can represent it as being 0 or 1, depending on what the actual digit is, times the power of 2. The place that we're in. Hopefully that makes sense. Let's just do some more so you can see. So this one's a 0, so we can do 0 times 2 to the 2, and we can turn off that. And so you can represent that as 0 times 4, which is 0. And so 1 times 2 to the 3rd. So it's going to be 1 times 8. That'll be 8. 8. Let's keep going. So 0 times 2 to the 4th is going to be equal to 1 times 16. Oh no, 0 times 16, my mistake. And so that's going to be 0. Okay, let's keep going. So 1 times 2 to the 5th is going to be equal to 0 times 30, or no, 1 times 32. Alright, cool. Let's keep going. Almost done. So 0 times 2 to the 6th, which is going to be 0 times 64, which is 0. And finally, we have 1 times 2 to the 7th. 7th. It's going to be equal to 1 times 128, which is going to be 128. And now we can take each of these and add them together. So just like we've been doing. So now we'll have 0, 2, 0, 8, 0, 32, 0, and 128, all added together, which is going to be equal to, let me just pull out my handy dandy calculator. So 128 plus 32 plus 8 plus 2, that's going to be 170. So that's the answer for 10, 10, 10, 10 in binary to decimal. 170. There we go. So yeah, that's another way to think about it. If you're just thinking about it this way, you can easily think about it this way. So maybe I should have showed you this one first, but I think you understand it pretty well, I hope. So again, just each of these, you can think of it as 0 times 2 to the power of whatever digit you're on. Of course, 0 is going to be the first, 1 is the second, and so on. And then you just do the math, which is 0 times 2 to the 0, so 0 times 1 is equal to, 0, obviously, and so on, right? And then you add them together to get the final decimal result. And then, of course, these are very similar. So we're just writing out the binary number, and then writing the powers of 2 underneath, and then doing the calculations by adding the results of each digit that is 1, and then we get the final decimal number there. And then just to recap the base conversion from decimal to binary, all we do here is just write out the powers of 2 again, and then we convert them into, the decimal form, basically. And then we do the calculations on that. And for each biggest number that fits into the number we're converting, we mark it as 1, and then do subtraction, and then keep repeating until we have 0 as the remainder. And then from that, we get the final binary number, which in this case was 11001. And yeah, so anyway, that's how you convert from decimal to binary and binary to decimal. Hopefully this helps you out. Alright, so I hope you enjoyed this video. If you liked it, leave a like. If you want to see more, subscribe. And peace.